Alright, so the optic nerve pathway. Essentially the path that is taken once the retina receives a stimulus that ultimately leads to us being able to see. But what happens when there are lesions in different parts of the pathway? Well, different visual anomalies can be seen based on where the lesion is. Let's start with a normal situation. Here we have the eyes, more specifically the retina that houses the photoreceptor and the neurons. The culmination of the axons of these photoreceptors form the optic nerve, which then runs posteriorly to reach the optic chiasm, which is where the optic nerves from both eyes meet. From there, we have the optic tracts on each side, leading into the lateral genicular bodies, followed by the optic radiations that ultimately take the signal to the occipital lobes, where the visual cortex is located and the signal is processed into an image that we see. One bit that people often get confused on is actually right at the start. The retinas in each eye can be labeled as either the nasal or temporal retinas, which refers to which side that particular piece of retina is located. So why is this important? So the temporal retinas are responsible for the nasal fields of vision, and the nasal retinas are responsible for the temporal fields of vision. Once that's clear, you just have to follow the paths. So we'll do these in different colors so we can try and keep things clear. Okay, so let's take this red line coming from the nasal field of vision, going into the eye and hitting the temporal retina of the left eye. The signal generated will then pass from the retina through the optic nerve into the optic chiasm, followed by the optic tract, and then into the lateral genicular body, where the nerve carrying it will synapse with another nerve that then relays the signal to the visual cortex. The same thing would happen in the other eye, with a stimulus coming from the nasal field of vision, shown by the other red arrow. Now, what if the stimulus comes from the temporal field of vision? We'll use blue this time, so the stimulus comes from the temporal visual field, and therefore will hit the nasal retina. From here, the signal will travel down the optic nerve and into the optic chiasm. The difference is that the fibers coming from the nasal retina actually cross the optic chiasm into the contralateral optic tract and then reaches the lateral genicular body on that contralateral side. Then from there, the signal passes to the next neuron via the synapse at the lateral genicular body and is taken into the visual cortex to be processed. The exact same process takes place when talking about the other eye. So now what you see is a representation of the two main pathways a signal could take, happening in both eyes for a total of 4 main pathways. Now let's look at what happens when we have lesions in different locations. You can work it out based on which bit of the visual field the neuron that has the lesion is carrying information on. For example, let's say we have a lesion on the optic nerve itself. This means that information coming from either the temporal or nasal retinas of the right eye can get through, and therefore nothing is going to be perceived as coming from that eye. So both the nasal and temporal visual fields of the right eye will be affected. What if, instead, we have a lesion at the optic chiasm? We know that the fibers in the optic chiasm will be coming from the nasal retinas, and we know the nasal retinas are responsible for receiving stimuli from the temporal visual fields. Therefore, if we have a lesion here in the optic chiasm, the patient will have vision defects in their temporal visual fields. This is why it's known as bitemporal hemianopia. Now let's say there's a lesion in the right optic tract. We know that it contains fibers coming from the temporal retina of the right eye, which is responsible for the nasal visual field. The right optic tract also contains fibers coming from the nasal retina of the left eye, which is responsible for detecting stimuli in the temporal visual field of that left eye. So, if both of these are affected due to some lesion in the right optic tract, the patient will have vision problems in the nasal visual field of the right eye and of the temporal visual field in the left eye. This is termed homonymous hemianopia. If you have lesions in the optic radiations, then if only one of the optic radiation tracts are affected, you may have quadrantinopia instead of hemianopia. Depending then on which part of the optic radiation is affected, you can have either a superior or inferior quadrantinopia. This of course also means that if the lesion affects all of the optic radiation, you get homonymous hemianopia, just like if the lesion was in the optic tract. In some cases, you have what's known as macular sparing. The macula is a portion of the retina that is responsible for the really fine central visual acuity that we use to read or watch videos. Specifically, a small piece of the macula is responsible for the really high resolution sight that we have, and this is called the fovea. The reason we see so well from this portion is because it has a high density of cones and 5 layers of ganglion cells. The interesting thing is that even today, they're not sure of why the macular vision is spared sometimes, but a main hypothesis are that there is a double vascular supply to the region of the visual cortex that processes information from the macula, one from the posterior cerebral artery and another from the middle cerebral artery. So, if one of these blood supplies is interrupted, the parts of the visual cortex that process the optic radiations may lose their ability to function, but the part of the visual cortex used specifically to process information coming from the macula may actually be alright due to its second blood supply. The visual fields of the patient would look something like this, giving them tunnel vision. This is also what patients with glaucoma and retinitis pigmentosa see, as well as people when they have used stimulant drugs like amphetamines or are sleep deprived. If, on the other hand, the patients lose the use of the macula, they lack the really high visual acuity that we get from this portion of the retina, so tasks like reading become extremely difficult. This can happen when the section of the retina where the macula is located becomes diseased. For example, when we have debris like drusen or even fluid accumulating beneath the macula, making it much more difficult for light to be detected by the photoreceptor cells. These conditions include diabetic retinopathy and macular degeneration.